All right, yesterday's lesson had to do with domain and range, but we were just introducing you to the concept of domain and range, and we are going to be going into different notations that you can use to describe domain and range. So the start thinking part here says Acme Home Supplies charges $5 an hour for a carpet cleaner rental, and then a flat $20 fee for using the chemicals or for the chemicals. You can pick up the machine as early as when they open, which is 11 a.m., but it has to be back by no later than when they close at 4. If you only use part of an hour, you will only get charged for that part of the hour. So you can work you can rent it for like 2.37 hours or something like that. And then I added this in as well. It is possible to just buy the cleaning chemicals as well. So you could go over and rent it for 0 hours and just get the chemicals. So at first the students went through and answered part A, B, and C. Part A is what is the function that describes the cost C for renting the cleaner for H hours. And we wanted to get this into function notation. So we got C of H equals 20 plus 5H. The next one says use words to describe all possible input values for the domain for the function. So on here, the fact that they are able to rent it for 0 hours and only pay for chemicals, that means that it is going to be greater than or equal to 0. And then the fact that they can pick it up at 11 a.m. and drop it off as late as 4, that is going to be 5 hours. So at most 5 hours. So the input values of the number of hours is going to be at least 0 and at most 5. Then it says we want to use words to describe all the output values or the range. So what's nice here is you can use those input values of 0 and 5, which are kind of the border of your domain, the border of your input values, to find out what the possible output values. So when you substitute 0 into your equation, that gets you 20. So you are going to be going at least $20 and then up to 45. So the outputs can be 20 or above up to 45. Now we came back together at that point and we said, how can we do this? I don't really like using words. Is there any more efficient way of talking about the domain and range? And these words that we see in here, like greater than or at most or at least, those all were words that we used when we were talking about inequalities. So we realized that you can write out the domain and range as inequalities. The one that says at least 0, at most 5, we can write as a compound and inequality of 0 is less than or equal to h, which is less than or equal to 5. And that represents all the possible values of how many hours you could rent this thing from 0 to 5. And then the range is going to be C of H, which is the cost for H hours, is going to be between $20 and $45, including 20 and 45 as possibilities. So what we learned here was that there is a way of using inequalities to represent the different domain and range. The next part here says that we have a situation. I've changed the wording of the situation slightly, and we're trying to figure out how this would change the domain. So the first one is Kira is offered a job where she initially gets $20. That makes $10 an hour for each hour she works. If she shows up to work, then she has to work at least 1 minute, meaning she can't just come and collect the $20 and leave. The other one is the same exact situation, but it says there's no rule saying she cannot simply show up, grab the $20 and leave. So how does this change the problem? Well, what it changes is there was the number that is in the domain, the number 0. The question is, do the input values start at 0 but not include 0, or do they start at 0 and can include 0? For the second one, 0 is a possibility because it says that she can just walk up and grab that $20 and leave. So she can work 0 hours, where with situation A, 0 is where it starts, but it has to be a hair at least above 0. We know when we've dealt with inequalities, that is the difference between saying like less than or greater than versus less than or equal to or greater than or equal to, figuring out if that border is also going to be a solution. Now, we wanted to look at a different notation. We have already looked at the notation talking about domain and range as inequalities, and now what we're going to do is talk about something called interval notation. There's a certain symbol that you use when the border is included versus when the border is not included. It's kind of like I said, less than versus less than or equal to, or greater than versus greater than or equal to. So right on here it says you are going to be using brackets when the border number is included, and you would use parentheses when the border is not included. And this is going to make sense in just a second when we look at some different problems. So when we're taking a look at these problems on the top, these do not have a domain and range. We're just trying to look at a number line and figure out how to use interval notation. So the first one is a compound inequality, and it is an AND inequality. It is going to basically have a border at -3 and at 1, and the numbers can be coming anywhere between those. You can see the inequality that we used there. Since it was an open dot at -3, it has to be just less than, not less than or equal to. But remember, when you're reading this, you're saying x is greater than -3 because the mouth is opening towards the x. And then it's got to be less than or equal to 1. So that would be the compound inequality that would represent all these. If we wanted to use interval notation, you put the -3 and you put the 1 because those are the borders, -3 and 1. And then, since it is an open dot on the left, that is going to be a parentheses. Since it is a closed dot on the right, meaning that 1 is also going to be a solution. It's not just the border, but it is also going to be a solution. You would use your brackets. So hopefully that made sense. The next one is going to be x is greater than or equal to -1 because it starts at -1. It's going towards the positive, so it's going to be greater than or equal to because it's a closed dot. If we were to write this using interval notation, you always want your interval notation to have the smaller number on the left and the bigger one on the right. So the smallest value that we have here is -1. Now, not only is -1 where the border is, explaining where the solutions start, but it is also a solution. That's why we had the bracket there. Now, the question is, how far to the right do we go? How far into the positives are the solutions? Well, this is going to go infinitely far to the right. So it's going to go infinitely far. What number does that get to? It doesn't get to a number. It gets to a concept, and that is infinity. So that is my way of showing infinity. I know it more looks like a sideways 8, but that is my symbol for infinity. That is what most people do, is a symbol like that. Usually there looks like a different type of 8 tipped on its side, but you might ask, why are you not using a bracket? And the concept is we can go towards infinity, but you can't really have infinity as one of your solutions, so it can't be included. It can't include. It's not like a border and it's also a solution. So that is why whenever you're dealing with infinity, you are going to use parentheses, not brackets. On the next one, we know this is going to be an OR problem. We've done these before in a previous unit. You're going to have x is less than or equal to -3, or x is greater than 0. Now, those are the two different ones. If I want to make the interval notation for the left one, how far to the left does it go? It goes all the way to -infinity. So that is going to say the solutions start at -infinity, and then they get all the way to -3. And -3 is the border of that part of the inequality. And since it is a closed dot, that means we have to use a bracket to say that not only is the border at -3, but -3 is also a solution. On the other one, it starts at 0 and it goes all the way to positive infinity. Now, 0 is not a solution, it's only the border, so you have to have the parentheses there. And as I've said, infinity is not actually a number. It's like the concept of going as far as you can to the right. So it's also going to be a parenthesis. And then you ask, what the heck is this U thing? That is called a union. You are basically having the union saying it is these two things together. Your solutions can be represented by these two things together. So there is a union between those two. Okay. Now we're going to get into something a little bit more challenging. Now what we're going to do is we're going to look at graphs that not only have x values, but they also have y values. So the concept here is, take a look at that first example. That first example is going to be created out of, you have this curve, and the curve is going to be created out of points. And those points, if I wanted to list all of those points as like xy coordinates, you have to have certain values to pick from to make all the x's, and you have to have certain values to pick from for the y aspect of the points. So your domain is basically asking, what are all the x values you need to be able to talk about all of these points? And then your range is going to be what y values do you need. A different way you could think about this is the domain is how far left and right it goes, and your range is going to be how high and how low does it go. So the domain, you can see the furthest left, if we picked all of these points and listed out what their x coordinates were, the smallest that the x's can get is going to be -3. So you can see that it starts at -3, and then how far to the right does it go? It goes all the way to 2. So it is going to be any number between -3 and 2 is going to be the domain, including -3 and 2. That's why it is less, or it's going to be x is greater than or equal to and less than or equal to the -3 and the 2. Okay. If we want to write that in interval notation, it is bracket -3, comma 2 bracket, because you are basically saying any number between -3 and 2, I need to have access to all of those numbers to be able to describe all the points, the x parts of the points. Now your y's is how low and how high does it go, because that is going to tell me what y values I need. So on here, how low does it go? It goes -1. How high does it go? It goes to 3. So when I'm generating my points and I'm picking, I need to have access to every number from -1 to 3 so that I can write my points. Every single point in this curve can be written using any number for x that's between -3 and 2 and any y between -1 and 3. And then you could generate all of those points. Now on the second one here, when you're looking at this, you can basically say domain is how far left and right it goes. How far to the left is it going to go? Infinitely far. How far to the right is it going to go? Infinitely far. So it is going to go from -infinity to infinity. How low does it go and how high does it go? What are the lowest y values I need and the highest y values or inputs? And you can think of that as an output, inputs for domain. Well, this thing is going to go as low as 1 and as high as infinity. And that's why it is going from 1 to infinity. And you do have a point that is going to have a y coordinate of 1. That's why you have to have inclusive 1. Now this next one right here is basically saying how far left, right, domain, how far up, down, range. Left and right, it is going to go infinitely far in both directions. That's why we needed -infinity to infinity. And how high and how low, it's going to still go infinitely far below, down and up. So that's -infinity to infinity. You can see how I've converted that into inequalities as well with the infinities. Now I am not using or equals to with my inequalities because -infinity and infinity are not actually numbers that we can use. Now this last one, we are only looking at the domain. So when you look at the domain of this thing, let's say you didn't even look at the graph. If you're just looking at the equation f of x equals 1 over x plus 2, and you're trying to figure out what are inputs, what are x's that I'm allowed to use here, you are allowed to use every single number except for -2. The reason why you can't use -2 is because then you'll have 1 over -2 plus 2, which is 1 over 0, and you're never allowed to divide by 0. So basically, this is saying you are going to use every single number for your domain except for -2. And you can even see on the graph, you are going to have how far to the left does it go? Infinitely far. How far to the right does it go? Infinitely far. But there's this little gap right where -2 is. And that is saying that you're not allowed to use -2. So I wrote that down as x is less than -2 or x is greater than -2. And then I would write that as 2 different interval notations with a union, -infinity to -2 and then -2 to infinity. And since we don't have the brackets at -2 on either one of those, that's just saying that -2 is the only number that we're not going to use. All right, that was the lesson. Now let's take a look at the homework here. On this one right here, it's talking about someone who already has 30 gallons of water in a kiddie pool. They're adding 5 gallons per minute, and the pool can hold at most 80 gallons of water. There's a safety mechanism that turns off the water when the pool is completely full, so it doesn't overflow. The function is going to be W of m equals 30 plus 5m, where W is the amount of water and m is the number of minutes. Indicate the domain as both a compound inequality and interval notation. So the question is, what is the least amount of minutes that you can be filling this? We are going to call it 0. We're not going to go into the past. So for this situation, we're going to start at 0. And then how many minutes can you do? Well, I know it only needs 50 more gallons. And if it's 5 gallons per minute, that's going to be 10 minutes. So basically, the domain is going to go anywhere from 0 to 10 minutes, including 0 and including 10. You can see that with the compound inequality. And then with the interval notation, you have from 0 to 10 inclusive with the 0 and the 10. The range, what is the least amount of water that's going to be in there? It's going to be 30 gallons. What's the most? 80 gallons, including 30 and 80. You can have both of those. That's why it's inclusive. Now, the next one says Molly makes $100 for a day for work and then $20 for each TV she sells. There's only 8 TVs in stock. The the function that represents the earnings E on that day after selling X televisions is E of X equals 100 plus 20X. List at least 2 general restrictions on the domain, meaning certain ranges of numbers that just don't make sense for the situation. So one of them would be negatives. You aren't going to sell negative TVs. Another one would be partial TVs. You're not going to have 3.75 TVs. And then lastly, you can't have over 8 TVs because there's only 8 TVs in stock. So those were the ones that I came up with. You can see my answers for number 3. You're going from -5 inclusive to 0. You can see how I did that as an inequality with the less than or equal to, meaning X is greater than or equal to -5 and less than 0. And you can see the interval notation saying inclusive -5 all the way to 0. And 0 is not going to be inclusive because it is a open dot. The next one is going to be X is less than or equal to 2. So the way that we do that is going from -infinity all the way to 2, including 2 because you have the closed dot. The next one is an OR problem. You have X is less than or equal to -3, and you have X is greater than -1. When you do this as interval notation, you're going to want to use your union, and you're going to go from -infinity all the way to -3 inclusive, and then you're going to go from -1 non-inclusive to infinity non-inclusive, because you cannot have infinity as one of the answers. Now we just have these ones right here. You're basically figuring out how far left and right it goes, how high and low it goes to figure out what are the necessary X values and Y values. You can see left and right, it's going from -4 to 4, including -4 and 4. And you can see how I wrote that both as a inequality and as a interval notation. The other one is going, how low does it go from 0 for Y, and how high is going to be 2. So it's going to be 0 to 2. Both of them are inclusive because they are closed dots on the end. The next one, how far left and right is this going to be going? Well, left and right, it's going to be going from -infinity to infinity. You can see how I wrote that as the domain. And then your range, how low can it go? You always want the smaller number first. It's starting at 1. You are going to have a point that needs the Y value of 1. So that is 1 inclusive, and then you're going to infinity, non-inclusive, because you cannot include infinity. And then lastly on here, we have a line. How far to the left and right does it go? It goes infinitely far to the left, infinitely far to the right. So what X values do you need? If you're going to write down every single point, you need to have access to every single X value, all the way from -infinity to infinity. And those are non-inclusive, as we've already talked about. And then how high and how low? Well, what are your Y values going to be? It's going to go infinitely high and infinitely low. So the Y values that you're going to need are every single possible Y value to create every one of these points on this line. So that's going to be from -infinity to infinity as well. All right, hopefully that made sense. Make sure you're careful with the brackets versus the parentheses, and then also with your inequality symbols, figuring out which way they go and if it has or equals to. Thanks for watching.